So in my last video, we came to know about the best smartwatch based on ESP32 chipset, which was TWatch 2020 version 3 from Liligo. And in this video, I'm going to show you how to program that smartwatch to build any custom project on this watch. And not only that, I'll also let you know how I made my own smart home control project on this watch, using which I can control up to 4 AC appliances, speed of 1 AC fan, and also able to monitor temperature and humidity on the tiny little smartwatch screen, which is awesome. And that too over internet using MQTT protocol. So this is the video which you need to watch to learn how to program the smartwatch for building any custom application. Let's get started. This video is sponsored by LTM, and they came up with an amazing product called as LTM365. So LTM365 is an electronics product design platform that unites PCB design, MCAD, data management and teamwork. So with LTM365, you can do the PCB designing task, you can share your projects over web for review purposes. It do cover sharing your PCB file to mechanical teams so that they can create the mechanical product package based on your PCB. Then it also provides centralized cloud storage, so you don't need to rely on one single computer for your files. It also helps you with managing your components and get real-time supply chain data for your components. It also allows multiple people to work on single project. And in the end, it also helps you with sending your design to final manufacturing units. So LTM365 takes care of all other tasks, so you put more time and effort in making something creative and useful. And the good part is you can try out its free version as well. I'll leave its free trial version link down in the description of this video, so do check that out. And now let us start with this video. So first of all, to program this TWatch, there are two prerequisites. First of all, we need to install the ESP32 boards packages, and for that you need to go to Arduino preferences. And here you just need to click on this icon and you need to paste this link, which I will be providing down in the description of this video. After pasting that link, click on OK once again, and then you need to go to Tools, into Boards, and then into Boards Manager. Here just type out ESP32 and just click on the install button. It will install all the ESP32 boards packages into your Arduino IDE, and the supported packages for TWatch will also be included in this. And second prerequisite is you need to install the TWatch library, and for that you need to go to the official GitHub repository of this particular Liligo TWatch. Again, its link is down in the description. You just need to, download this zip file of this particular thing. I'll click on the download zip button. It will automatically download this zip file. And after downloading, you need to go to Sketch, into Include Library, into Add Zip Library. Now here, go to Downloads and search for the file which you have just downloaded, which goes by the name TTGo TWatch Library Master. Okay. So here is the TTGo TWatch Library Master. I have already downloaded it and installed it as well. So when I click on the choose button, it says the library already exists. But in your case, if you don't have the library, it will automatically install. That are the two prerequisites. Now we are good to go to program our smartwatch. So you can go to the file, into examples, and then scroll down and down to this TWatch library, and here are the built-in examples to get started with this particular watch. There are enough examples to test almost all the peripherals of the smartwatch. I won't be going through all the examples, of course, but I'll let you know a couple of examples, and using those examples you'll come to know how to upload any sketch into the TWatch. Now let me tell you, all the examples provided here are not supported in this TWatch. Some of TWatch version 3, okay, some of the examples are for version 2, for version 1 and stuff like that. Okay, so how we can come to know about whether the code supported for this version or not, I'll let you know while uploading a sample sketch. So let's start with the hardware test. Now this is the best example to test all the hardware peripherals of your smartwatch, whether they are working or not. Okay, so you can upload this code to test all those things out. Okay, so this is the code, and here inside the config option you need to uncomment your version of the smartwatch, which is Liligo Watch 2020 version 3 in my case. Okay, so here you can find out that is this code supported in the particular version of the smartwatch or not. So by this particular config file you can come to know about that. Okay, that's pretty much it. I don't think any other change we need to do here. Okay, so now we need to select the right board. For that we need to go to Tools, into the board, into ESP32 Arduino, and when we scroll down we'll get an option called as TTGo TWatch. You need to select that option. After that, once again go to Tools, and go to port and select the right COM port on which your ESP32 watch is connected with. Okay, after that just click on the upload button, and it will take some time to upload the code because the code is really very big. Okay, in the meantime I'll turn on the smartphone and let you know the working of the code in the watch. Okay, so the code started uploading on the board. It took a really lot of time to compile the code, but yeah, it's finally uploading, and yeah, it's done uploading. Let's just go to our smartwatch, and yeah, it started doing something on it. Let's just click on the screen. Nothing is happening. Let me open the serial monitor. Nothing on the serial monitor as well. Let's just press this button. Okay, now it started. It says playing audio. Okay, it's playing the audio. Let me take to the mic. Okay, audio stop, and now it is scanning the network. So it is testing the Wi-Fi. So yeah, these are the Wi-Fi networks available nearby the smartwatch. So Wi-Fi is working perfectly fine. Touch test. Click the button to skip. Now let's just not skip this. Let's just test it out. So yeah, this is the touch test. So touch panel is perfectly working. Let's press the button. And it tested all the other ICs, okay, the AXP202, the charging IC, the accelerometer, and all other IC tested, and all are working completely fine. So all IC got tested as well, and yeah, this is the X and Y coordinates of the touch panel, so that is also working fine. Let's just click on the button, and I think we are done with almost all the things. Yeah. So yeah, we are done with almost all the things. We tested all the peripherals of the smartwatch. So this is the important example which you should upload to test out your complete smartwatch. Okay. Now, if you are confused whether we will be able to get the previous built-in firmware or not, well, don't worry at all. I'll let you know how to get the previous built-in firmware of the smartwatch at the end of the video, so stay tuned. Okay, so as I said earlier, I won't be going through all the other examples, but I shown you the way about how to use the examples, how to upload them into the smartwatch and use them. You should definitely test out a couple of example codes to know more about how to program this watch. Okay, now what I'll do, I'll let you know some interesting application which I found online about this particular watch. So I'll take you to the YouTube channel. So this is from the Vola's project, and he tried to create his own smartwatch, or the watch face you can say, which is really interesting. It has a lot of widgets on the watch, and I found it really attractive. So I just downloaded the code which is available on his GitHub repository, and after that I uploaded the code as well. Let me just open that code, and here is the example code. I'll open this example code with my Arduino IDE, and under the config section, I just rename it to version 3, and that's pretty much it. We can directly upload this code to see the watch face on our watch as well. Pretty interesting. Let's just wait for the code to get uploaded. Okay, so the code started uploading on the watch, and it's done uploading. So let's just have a look at the smartwatch, and here is that watch face. It's pretty amazing. There are a lot of complications provided on this smartwatch. Like here is the day. Let me just turn it on. Yeah. So we have seconds, we have hours, minutes, and we have the day and everything. There are a lot of we have the battery level as well. There are a lot of complications added to the smartwatch face, you can say. I find it pretty interesting and just shared that with you in this particular video. There is one more interesting project from that same YouTube channel which I loved it pretty much, and it's about a slide changer using this ESP32 based smartwatch. Okay, so he will open up the what you can say PPT in his computer. And yeah, he's changing the slide with the help of the smartwatch, the TWatch 2022 via Bluetooth connectivity. So he's using this ESP32 watch as a BLE keyboard, and here are the buttons on the watch, and he's able to control or change the slides using the smartwatch, which is pretty amazing application. A PPT controller, you can say, a slide changer, you can say. Okay, so unfortunately he didn't give the code for it, like how he made that. Rather, he shared the library using which he made this code, which is the ESP32 BLE keyboard, but no code at all. Okay, do you want me to try out this particular project and share the video of it as well on this YouTube channel? Well, do let me know your thoughts down in the comments of the video so that I can put more efforts in this particular thing as well. And as we are talking about the interesting application of this smartwatch, well, I also tried one really interesting and awesome application on the smartwatch, which is to control my studio appliances via internet using this smartwatch interface based on MQTT protocol. So in that project, other than the smartwatch, we have used couple of other components as well to control the appliances. So here I used the home automation version 2 made by team techiesms, which we are also selling it on our website, and using that board we are able to control up to 4 AC appliances and speed of 1 AC fan, and also able to monitor temperature and humidity data as well. And well, I can't move ahead with this project until unless I tell you about how I got the PCB manufacturer for this particular project. So I got it manufactured from jlcpcb.com, and even you can try ordering your own custom PCBs from jlcpcb by following very simple steps. You just need to upload the Gerber file of the PCB project, select the number of PCBs and color masking, and just place your order. And now if you select the fastest delivery option, well, you may get the PCBs delivered at your doorstep within 1 week. So I tried JLC PCB for a couple of times for my PCB project, and hence I can definitely recommend to you as well. And other than PCB manufacturing services, JLC PCB do provide other services which are PCB assembly service, in which you'll get all the SMT components on one layer of the PCB already shouldered from the JLC PCB. Not only that, they also started the 3D printing service where you can upload the 3D print design and you can get the 3D printed material delivered at your doorsteps as well. So I'll leave the link for all those things down in the description of this video, so do check the services out. They are pretty amazing. So now in this video, I won't be covering the coding part of that particular home automation project because I already covered a lot of time in other videos. Okay, now let me show you the working overview about how this project is working. So in this project, there are 3 major components: the smartwatch, the home automation project, and in the middle, the Adafruit MQTT broker. Okay, so Adafruit is the cloud MQTT broker through which we'll be sending and receiving the commands, and both the smartwatch and the home automation project are the MQTT clients which will be sending and receiving the data via MQTT broker, and this is how our project will be working. Again, I have explained in detail about how to use Adafruit MQTT broker, how to make an account, how to use it on ESP32 in one of my videos, whose link you can definitely find in the description of this video. So now let's just focus on how to code our smartwatch to send and receive data via MQTT, and how to create those buttons and sliders and such amazing widgets on it. Let me take you through that particular code. So I'll open that code straight away. So yeah, here is the code, and here I included the Adafruit MQTT library, provided my Wi-Fi credentials, provided the credentials of Adafruit MQTT broker, pretty common. And what is not common here is how I got this buttons and sliders. Okay, so this is the complete code of it, and at a first glance, it definitely looks really very confusing. But let's just go step by step and let's just see how to create one single button on this particular smartwatch. Well, here one amazing library comes to our help, which is LVGL. Well, now if you don't know what LVGL, then LVGL stands for Light and Versatile Graphics Library, which is free and open source graphics library for these tiny little microcontrollers. And using this library, we are able to build the buttons and sliders and all the other widgets. Okay, so what you can do is you can go to the widget sections, and it will tell you what kind of widgets this library offer. Okay, for example, if you want to add a button, we can go on to the button section, and it will let you know everything about that button. And not only that, it also show you how the button looks like. And again, not only that, it will also share you the code in C++, or you can say Arduino IDE. So you can definitely copy this code, paste it in your main code, and you will get a button on it. Again, not only that, it also provides the code for the MicroPython as well. Pretty amazing documentation, pretty amazing and stable library for sure. Okay, so here you can copy this code and you can change the parameters. Like if you change the name of the button, you can change it here. If you want to change the action of the button, you can write down the actions here, and you can do all the tasks. Okay, so in my case, let me show you the task which I have assigned to one of the buttons. So for the button 1, which is here, what I'm doing is I'm printing relay 1 toggle on the serial monitor, and I'm changing the status of the relay, which is a boolean, and after that I'm publishing the data of relay status 1 into the relay 1 topic. This is simple task I'm doing using the button 1. And similarly, I've created 4 different buttons. Okay, and for the fan speed control, I use a slider, and for that you can get the code from the same website. You can just click on the slider option, and here you will get a slider widget like this, and you'll get the code for that as well. Pretty amazing, right? So you can copy this code, you can paste it in your main code and get a slider. And also I have used the what you can say bar, you can say, for showing the temperature and humidity data. So you can click on the bar widget and you can get the data or code for the bar widget as well, which is pretty simple. Okay, so after collecting this small code and pasting here in the main code, I have created this complete code. So I'll be providing this code free of course on my GitHub repository, and you can learn this code and you can modify it according to your MQTT broker. You can change the MQTT broker as well and make it work on your side as well. So yeah, this is all about this code. I will select the right COM port and right board, which is already selected, and I'll directly hit the upload button and I'll upload the sketch into the smartwatch. And in the meantime, I made the connections of my smart home project with my home appliances according to this connection diagram. So now let me show you the working of this complete project. So here's the complete control on the watch, and at the first glance we are able to see the temperature and humidity sensors data on the screen, which is sent after every 10 seconds by the smart home project. Okay, now let's try controlling the appliances. Okay, so as you can see, I'm able to control those lights using the buttons on the smartwatch, and it is pretty responsive, pretty smooth as well. It is sending the data in real time thanks to the MQTT protocol. Now let's try out with the fan speed as well. Well, the slider is pretty smooth thanks to the capacitive touch panel, and with that slider, I'm able to control the speed of the fan as well. And this whole thing is working over internet, so you can control it from any corner of the world. Well, do click the like button if you really loved the project, really loved the concept, and really loved the hard work that we put on to make this particular project. Okay, so we already seen enough about what this smartwatch can do and how you can use it for your custom projects. But now let's come to the basics once again. How to get that previous amazing smartwatch firmware back to our TWatch 2022? Well, we can get it very easily, and let me show you the steps about how to, dump that firmware, the built-in firmware, into the smartwatch once again. Let me show you. So now I'll show you the demo of how to go back to the previous firmware on a Windows system. So first of all, you need to download one flash download tools from the official Espressif website. I'll leave its download link down in the description, and you need to download this particular software. In my case, I have already downloaded, so I'll quickly open that up. So here's that file, and here is that software. I'll quickly open this up, and this is used to upload the binary file into ESP8266 or maybe ESP32 chipsets. Okay, so you have to select the chipset. So I'll select ESP32 and work mode as developed. So it will open up a window like this. Here we need to provide the firmware file and the address. Now how to get the firmware file? Well, you can get the firmware file from the official GitHub repository from Lilico about TWatch, TTGO TWatch library. This is the same zip file which we have downloaded and installed into our Arduino IDE. So if you go into this particular library file, if you go inside the bin folder, you'll get the binary file of all the versions of smartwatch. Maybe it's 2019, 2020, V1, V2, V3. Okay, so these are the firmware files of the built-in firmware, and here you need to configure that flash download tool according to this configurations. Okay, first let's just select the configuration as shown here. So it is showing as 80 megahertz and it is SPI mode as QIO. Okay, great. So now what I need to do is I need to download this complete zip file, and I need to switch on to 2020 version 3 binary file. So here is that binary file. So what I did is I downloaded this complete zip file, and after that I extracted that zip file, and it is extracted into my downloads folder, and I can easily access that particular binary file by going into this particular folder. Okay, so here's that binary file, and this is the file which I need to flash onto my ESP32 watch, you can say. Okay, so for that we'll open up the flash download tool once again, and here what I'll do, I'll click on this 3 icon, and here I will go back to my downloads folder, into the TWatch library folder, into the binary folder, and then to 2020 version 3, and select this particular bin file. I'll start with the address 0. I'll check mark this box, and what you need to do is you just need to select the right COM port on which your watch is connected, and just press the start button. It will start flashing that built-in firmware onto your TWatch 2020. It will definitely take some time, so let's just quickly fast forward this video. Okay, so the file is successfully flashed onto our TWatch. Now let's just unplug the USB from the watch, and let's just press and hold this button, and let's see if the firmware got flashed or not. Okay, it got vibrated. Okay, I got that previous booting animation. That means we successfully flashed that previous built-in firmware once again to this watch, and let's just see if we get that watch face or not. Okay, so we got that watch face, we got that Wi-Fi, GPS icons and everything, all the applications, widgets, everything we got, which we were getting at the time of, unboxing this particular watch. So this is how you can, flash the previous firmware. So with this process, you can be on the safer side, like after trying out a couple of projects on this watch, and if you want this watch to be working as it was working before, you can flash this kind of firmware and it will be working as it was working before. So yeah, that was all about how to program this watch using Arduino IDE. I hope you find this video useful, interesting, and I also showcased the project which I made, which was controlling home automation or controlling home appliances using this smartwatch. As I said earlier, we are selling that home automation project on our website at an amazing price, so you can click the link in the description, get one for yourself, and maybe you can make your own home automation projects using that particular circuit. That was it about this video. Do share your thoughts, suggestions, ideas about what we can make more onto this TWatch 2020, and I'll definitely try out some interesting project ideas, and if that project idea is converted into the working project, I'll definitely make a video of that as well. So do share your ideas down in the comments of the video. And yeah, that being said, I'm just ending this video here, and now just wait for my next video, then explore, learn, share with me, techiesms.